Hey guys, it's Standing for Truth coming to you live here tonight on this late Monday night for a good discussion here with frustrated atheist. It's looks like the topic's going to be creation, evolution, atheism, theism, and things like that. I'm sure it's going to be fun. I'm going to introduce frustrated atheist, who's going to tell us briefly about his channel, and then give us anywhere between maybe 3 and 5 minutes, just description of where he's coming from, what he believes in, the model he holds to. I'll do the same, and then we'll kind of go back and forth point by point and have some fun. Okay, frustrated. I'll leave it to you.
Alrighty. I am frustrated atheist. I have a channel where I do a bunch of different science-related topics, and I also debunk a lot of nonsense that gets spewed out. And that's pretty much what my channel is about. I um, am in the process of doing a science series. That's called Science for the Newly Deconverted, where I take all the science that we get thrown at when you become an atheist, and that's pretty much about it. Um,
Awesome. And if anyone wants to check out Frustrated Atheist channel and subscribe, go ahead. I'll leave his channel in the description box when this is done and over with. And if you want to start by giving us just a brief explanation, kind of opening statement on where you're coming from and what you believe.
well, um, I pretty much I'm an atheist. I don't believe in any god or gods. At least not the ones not the ones that have ever come to light from anybody. Um, and I'm actually a strong atheist, which means that I believe that they do not exist, like gods do not exist. Um, Other than that, I don't know what more you need for that.
Like, what would you like? Do you hold to, obviously, to universal common ancestry? Like, hey, maybe just give
Oh,
a brief explanation of, say, your, a few of your top evidence of how what you feel maybe proves that, or just a few brief things that we'll probably end up getting into discussion wise.
oh, well, I do hold to common ancestry. I do believe that we all have a common ancestor. Um, and the further back in time you go, the more narrow it down it does get. And I do hold to the scientific understanding that we do have of the universe and how it works and how everything is the way it is. Meaning that I do believe that evolution is a fact. I do believe that the Big Bang Theory is a fact. Uh, and yeah, that's I again there's not much to go into on that. Just
Uh,
that whatever you feel like addressing at the moment, I'm okay with.
Sounds good. Yeah, and I'm sure there's going to be plenty to discuss and kind of things that are just going to come to our mind. With me, I hold to obviously a biblical model. I think when we look at the empirical evidence, I think it points to limits and a barrier. I think it points to decay and degeneration. But I think when we're looking at, say, the secret of life, the origin of species, the origin of traits. I think we can look back to Darwin, but we can also look back to Mendel, because Mendel, I don't think Darwin was very much aware of him, and obviously Darwin wasn't very much aware of genetics. So Mendel, he found concerning traits that they remained distinct, right? So they didn't blend. They kind of appeared and disappeared in family trees, right? In other words, they came in dominant and recessive types. And, you know, the fact that obviously Darwin wasn't apparently aware of his work, we can see that these changes, you know, can come about quite quickly, actually, based on his experiments with the with, I think it was plants, pea protein, or pea plants. I think when we would look at um, explaining, obviously, because if we look at the young earth creationist model, it would envision 3 bottlenecks, right? And I think that's important in regards to our model. I mean, we look at Adam and Eve, the flood, and obviously the Tower of Babel dispersion. So we would see that each bottleneck, it followed an exponential population growth. So we would explain that by, you know, most of the nuclear DNA differences in other species and in Adam and Eve, who we say would have that, you know, built-in designed variation, they were built in at creation. So we would be looking to, say, functionality in the genome. So we know that roughly 2% of, you know, the protein coding regions are about 2%, and the rest would be non-protein coding regions. So we would predict that those regions are functional. But for evolutionists, in regards to genetic change, you know, obviously the ultimate cause, and we can get into this, would be mutation. But where I'm coming from is, since the mutation rates are slow and the number of, say, DNA differences, whether it's in, you know, mitochondrial DNA, nuclear DNA, they're pretty extant. You know, they're pretty large. So there'd be a lot of time required to explain the current diversity that we see. So really, it just comes down to us as creationists. You know, we look to heterozygosity, right? Millions of differences in DNA sequences of chromosome pairs. We say they're built into organisms from the beginning by the creator. Therefore, you know, long periods of time, they're not really required, say, for the production of the new species. Because really, starting with, you know, heterozygous organisms, the visible distinctiveness, and we can look to Mendel for this, and his study of the pea plants. You know, the visual distinctiveness in offspring, it would be apparent. So recombination, gene conversion, things like this would provide many new varieties of combinations of traits quickly, obviously, since the difference is already built in. So we believe that, obviously, you know, a lot of what we see here is a variation based on that pre-existing heterozygosity, pre-existing DNA differences and information. Now it's just kind of a downhill sorting out process, and we're going to see traits and varieties based on that. And I think that's where the debate comes down to, you know, what type of change are we looking at? Are there limits? Are we decaying? And, you know, I think I'll end with that, and maybe go into a question to you, and ask you, do you believe there are limits, frustrated atheists? Like, how would you, what type of limits do you see regarding species? Go ahead.
Well, as far as species go, when you come to limits, yes, of course, everything has a limit. Um, but I'm more curious right now in understanding this. What do you mean by decaying? When you were
I
talking about the
Yeah,
body.
I think okay, and that's a good question. I think a central part of that information, or of that argument, say, with, I would call it genetic entropy. It's just that, say, mutations, which we know are, you know, typographical, spelling mistakes, errors in DNA, they're accumulating so quickly in some creatures, particularly obviously human beings, that natural selection, they're not going to be able to stop the functional degradation of the genome. So really, you know, that's going to be a tough way to drive the evolutionary process. And just to make it simple, you know, in an analogy, it's kind of like rust slowly spreading throughout a car over time, right? Each little bit of rust, say, akin to a single mutation in an organism, is almost inconsequential, obviously on its own. But if the rusting process cannot be stopped, it's eventually going to destroy the car. Kind of like the near neutral mutations are slowly building up in the genome and degrading us over time. Does that make sense?
Yes, but the thing is, I have an issue with that because the only place I ever hear of entropy that has to do with anything within the body and whatnot is through especially young Earth creationist camps, and it's not anywhere in science. The only time science ever talks about entropy is when it comes to energy, and not a genome. So I'm curious on where you get this understanding of genetic entropy.
And good question. I would say that entropy in the way that I'm describing it wouldn't be like, it still is consistent with the second law of thermodynamics, obviously, but we're talking about entropy on a biological level. So that accumulation of near
And
neutral and obviously deleterious mutations in our genome. So biological entropy, not
ag-
necessarily. If you look into, say, genetic entropy, the book, Dr. Sanford, he would say that it's kind of a trade secret among population geneticists, right? Because they do agree that we're degenerating, but they invoke, and I admit to this, they invoke natural selection, beneficial mutations. But the question is, does natural selection and do beneficial mutations account? And can they combat this, accumulating damage in the genome? So I guess my point is evolutionary population geneticists, they do agree that we're degenerating, but they answer the problem with natural selection and with beneficial mutations. Does that make sense?
yes, but the thing is I don't, again, and maybe it's because I'm not familiar with the what did you say, population geneticists.
Yeah, like if
I'm not familiar with any people like that, but I don't. Entropy, the word itself, is usually used within science as far as energy goes, and that's what the second law of thermodynamics is about. Is is energy, not genome.
no, no,
So
I think in general, like the word, if you look in the dictionary, the word entropy, it's just, things are winding down, things are decaying, degenerating. So obviously we know that, the universe is winding down, the law of increasing entropy, but I'm not referring to that in regards to the word entropy. I'm just using the word entropy in regards to our genome. Because if we look at this accumulation of near neutral mutations, because we know that genomes, obviously they're the genetic specifications that allow life to exist, right? So this means that, and I don't know if you'll agree with this, and I'd like to hear your thoughts on it, that random changes in these specifications, right, of our genome, they're going to disrupt information with a very high degree of certainty. And if we look at ENCODE, the results, I understand that they were looking at what was transcripted. They're actually, looking at nucleotides and how they play a role in multiple overlapping codes. So that actually makes beneficial mutations, which are, not deleterious, to be actually really, really rare. Because if we're looking at, say, a genome that has chock full of information that's functional, any small change, no matter how diminutive it is, it's going to be deleterious to our information systems. Go ahead. How do you feel about that?
that was a lot of just random words, in my opinion, of what you just said. Um, so I had no idea what you were
Well, like, do
talking
you
about.
believe that? Well, like, for example, a near neutral mutation. Like, how would you define a neutral mutation?
A neutral mutation,
Yeah.
that'd be just anything that is not necessarily it's a mutation that has occurred uh within an organism that may have may not have been originally there, but it has no effect on the organism in a positive or negative manner.
Yeah, so it's a mutation that's neither beneficial nor detrimental, right?
Right,
So
but
it's going to build up in the genome because natural selection is not going to select against it, nor uh, you know or for it. So regardless, it's going to be deleterious to the genome, and over time, it's going to build up, say, in the population. Uh, and these slightly harmful mutations, they will build up to a point that, say, in combination, they will start to have effects on reproductive fitness. So if you think about it, like this downward spiral I'm talking about, it's almost like it becomes unstoppable because now
okay,
every member of the population has that same problem. Go ahead.
okay. So you don't believe in any beneficial mutations whatsoever?
No, no, I think it depends on how you um, describe a beneficial mutation because I do believe in beneficial outcomes, and I believe that mutations, especially in regards to say a beneficial mutations, quote unquote, it's very environmentally dependent, right? So it's going to be possibly beneficial in one area, but then it's going to be deleterious in another. Like, for example, do you agree that genetic diseases are increasing? Like, do you think that we're seeing a lot more of these mutation related diseases? Because we can see that there's just so many overwhelmed. How do you feel about that?
Um, I have no feelings on it whatsoever because I have no idea. I don't pay attention to a lot of these diseases that come across, especially due to mutations. But what I'm trying to ask is that so you believe that we do have beneficial mutations, but they can also be harmful.
Yeah, I would say because they're environmentally dependent. I would say that, I mean, I think it would be best if we looked at some examples. For example, like if we looked at, the HIV example, and I think you're familiar with that mutation, that gene. What's the specific gene actually that it's affecting?
The HIV.
Yeah, like the one where these people have a mutation that now, and correct me if I'm wrong, I think it prevents HIV from entering the white blood cells and replicating. So now it's making them unlikely to develop AIDS. It's a
Oh,
certain,
are you talking about the mutation that occurs in about roughly like 1% of North Europeans?
yeah, yeah. So like if we look at that, because that's a pretty substantial example of say a beneficial mutation, obviously. But if you actually look at the studies, for example, it actually reveals that these individuals may actually be at a higher risk of developing illness associated with like West Nile virus and hepatitis C. So we see that the mutations, obviously, in this example, they're only beneficial in a given environment, such as obviously if the person was affected by HIV. But it's obviously evident that the mutation would not be beneficial in other environments, right? Say if they were exposed to
Yeah,
I don't
because
know, West Nile virus.
that's because that's how natural selection works. It's if you have a mutation, um, a lot of the times it will be there's a strong correlation between the mutation and the environment that you are in.
Well, so I think the question, so obviously there's no question that, mutations can be beneficial. And it seems like we agree to this in certain environments. But the question is, do they lead to the like origin of novel traits, say, the type necessary for molecules to man, pawns come to people type evolution? Do you believe that these types of examples, even though they're slightly deleterious in a way, can lead from, fish to fisherman? Like if
Um,
you look at Haldane's dilemma, I mean, you can see that
so
major problem. Yeah, go ahead.
so hold on. First, I'm gonna have to mute myself for a minute, as I've explained to you beforehand. So just give me
Yep,
1 second.
no problem. So how's the chat going here? I think before he comes on, I'll because I use the Rust And I'll just talk here because we don't want to get bored with the audience. But another analogy that would be good, guys, is imagine a copy of, say, the Encyclopedia Britannica on a computer, say that has a virus that randomly swaps, switches, deletes, and inverts letters over time. For a while, there would be almost no noticeable effect. But over time, the text would contain more and more errors until it becomes meaningless gibberish. So, in biological terms, mutational meltdown would have occurred. And I think genetic entropy is kind of a slam dunk against. Hey, Fresh, are you
Yeah,
unmuted
I'm
now?
back. Yeah, I'm
I was
back.
just kind of okay. Go on. I think we were talking about the obviously beneficial
Yes, the
mutations.
mutations. Yes, so the thing is what is that? Give me a sec.
No problem. And I think frustrated atheist just has to mute himself once in a while because he's doing this from
From
work.
work.
So
Yeah.
we're just yeah. I
Okay.
think, and I want you to go into this. I want you to also kind of address Haldane's dilemma because obviously, if beneficial mutations on one animal, say, has to spread, to the population for evolution to occur. So based
Well,
on the known mutation,
the thing is evolution happens to populations. It doesn't just happen to single individual and creatures. It happens at a populational level.
yeah. So
This
like
isn't
evolution.
something that just happens to individual creatures and then hopefully they run into another creature that has the same beneficial mutation type of thing. This is something that happens at the population level.
Yeah. So would you say evolution, in regards to, fish to fisherman type evolution, can be defined as a change in allele frequency in populations over time? Obviously, not individuals are evolving, populations are evolving over time, right? Gene pools are evolving. But the thing is, this
Yes, that
beneficial
is
mutation, it's still going to have to become fixated in the population without it being, diluted down back into the population. That's where I think the dilemma comes into play. Go ahead.
um what the hell was that you just said?
So it's called Haldane's dilemma. So it's just referring to, because obviously if we do get a beneficial mutation, say on one
Mhm.
animal, it's going to have to spread, through the population for evolution to proceed, and then it has to
I,
kill the population without this new beneficial mutation because it might get
right.
diluted down back into the pop because it
Well,
has to be
look,
fixated, right?
so no, so you see, the thing is when it comes to beneficial mutations and whatnot, they happen to an entire population. Take for instance, I know you're not going to accept these because you of course don't believe in that these are indeed what they are. But take the transitional creature of Tiktaalik. So you have a creature that was before it that had shorter, not so thick fins, and then you have Tiktaalik, who has a harder fin and almost not exactly a leg or anything, but a harder fin to swim in areas that are closer to the shore. Um, the both creatures will still live in the exact same time frame as each other, regardless of the uh, what you call it, regardless of the fact that they are two uh, different creatures in a way. They're going to be in the exact same things. The same thing that happened in the human line when you get to things like Australopithecus africanus and afarensis. These are two totally different creatures, but they lived in the same time period for a little while together. And we even lived with I think it's afarensis, for a little while when the um, Homo habilis came around. So you'll have these creatures that are of the same lineage, but they are different, still living together. They don't
Well,
necessarily have to kill each other out. As a matter of fact, we know this in one of the most recent finds of the very first it was the very first generation of half Denisovan and half Neanderthal, and
well, I just
both
want to make.
lineages.
Yep. No, and I just want
Go
to make
ahead.
one comment, and I'll get into maybe some of those specific, fossils that you're talking about. But if we don't see these, information adding, meaningful, beneficial mutations today in a population, aren't you kind of just extrapolating,
No,
that information and interpretation from the present
no,
to the past? Like, aren't you kind of just putting that evolutionary assumption on? Because if we look at Tiktaalik, and correct me if I'm wrong, wasn't there like a Polish footprint discovery where tetrapods, a 5-digit pattern, I think it was, even before this Tiktaalik mosaic creature was found? So wouldn't that kind of push back the timeline and create
no,
problems?
because the thing is you're one of the most beautiful things about science is the fact that it is ever changing. It will change eventually to more accurately depict what has happened. But I've heard of these footprints. I haven't looked into them, but I have heard of these footprints. But that doesn't necessarily mean that it is wrong. I mean, for instance, we know of like for instance, we have the
Well, real
crap.
quick,
Give me a second.
and keep going with that. But I'm just saying, like, if we're talking about these beneficial mutations, as in like an information adding, obviously deleterious mutation, because I think it comes down to net loss versus net gain. If it's rare for, say, one animal to get this type of beneficial mutation, how hard is it going to be for an entire population to get this fixated beneficial mutation? Because if we don't see that today in the present at a genomic level, that means if we're looking at these fossils, these bones found in the dirt, because at the end of the day, we
So,
look at animals like penguins, right? There's a mosaic animal. Look at a platypus. There's a mosaic animal. So if we see a mosaic animal in the past in the fossil record, we're just putting our interpretation on that fossil, right? So it doesn't necessarily mean that it's true. We need to look
well,
at the present. Go ahead.
the thing is that you don't you're not exactly extrapolating anything, because, for instance, right now we may, even if we have no beneficial mutations happening in the present,
Well, like,
doesn't
what would be
mean.
I guess if you had to just throw out a couple really solid examples of, say, new novel information, meaningful information being added to the genome that's not deleterious in any way, because obviously you're not going to get rich by losing money. What would you say that example would be? 'Cause I understand there are some good examples, but what example would you
Of
provide?
a beneficial mutation that is today.
Yeah, like a beneficial mutation that
Okay.
actually adds,
Um,
new information to the genome.
there's the ApoAIM mutation from the ApoAI gene. It's the gene
It's
that it happens
I just want to
in
be on the
a
same page.
singular.
Is this the melano protein, or is this the melano
Yes,
mutation?
yes,
Is that where, like, one amino acid has been replaced with a cysteine residue in a protein that normally assembles, say, high density lipoproteins? And obviously we know those are involved in what, removing bad cholesterol from arteries. Is it that one? So it's kind of
yeah.
better protected
It's
against atherosclerosis.
yes,
So if we actually look, though, at the mutant form of the protein, it's actually now less effective at what it was supposed to do, because now it does, I agree, it does
but
act
it
as an
does add. But the thing is it's not necessarily because this particular gene does that function, and it does the mutated version of it does lose. effectiveness, but it
Yeah.
doesn't completely get rid of it.
Okay, so would you say that it
So
is, in a way, a loss of specificity? Like it's a loss of specificity that is now resulting in an amplification of a pre-existing gene or protein, I should say. Because, in other words, the specificity, as you were saying, of, say, the antioxidant activity for the lipids, it doesn't really lie with the mutation itself, but with the protein structure. But that already existed. So it's just an amplification on pre-existing information. But since we predict pre-existing heterozygosity, pre-existing DNA differences, it's just a trait being revealed or amplified based on the pre-existing information. So it's not really anything new, novel, and meaningful. Go ahead.
okay, well, for starters, I'm going to need some kind of source for your for this claim here that you've said that about because I would love to look it up myself.
Well, you just
Um,
admit, but well, I just correct me if I'm wrong. Didn't you admit that the protein has lost a lot of activity for making HDL? So now the mutant protein has sacrificed specificity.
I didn't see that. I didn't say that it loses a lot. I said that it might. I mean, because
Okay.
I don't personally know much about that as far as it goes of that. I just know that it is indeed still a beneficial mutation because of the added function that it does.
No, and and
So
and
any source that you have, I would love to look at, is what
Yeah,
I'm saying.
no, and I'll send you the sources and the articles that I've studied and looked into. But I'm just saying that the fact that, say, whoever these people are, I think it's a small population with this specific mutation. They're obviously unable to produce the normal levels of HDLs. Okay, so that is good, but we know that those are known to perform, and you might be aware of this, a valuable role in moving the bad cholesterol. So that suggests there could be, and you also said there could be, a health downside with this mutation, kind of like sickle cell anemia.
No, I'd never said that there's a health downside
Well, the thing is,
because it
if
still does the same function that the original gene does. It has an added function to it though.
but what I'm
So it
saying
still
is,
does the function. So I mean, it's like saying you're the thing is this is going you're trying to make this seem like it doesn't do the original function it was meant to
well,
do
no, I understand it
because
does,
it does.
but it's sacrificing some specificity to do so. But it's also, even if I concede that it's a truly beneficial mutation, it's really still just an amplification of a pre-existing protein. So there's nothing novel or meaningful, because remember, in our model, we predict that pre-existing heterozygosity
Well,
was pre-existing.
the thing is about mutations is that mutations that are beneficial are still beneficial regardless, even if you do lose a little bit of the function of the original one, of
Well,
the
the thing is,
original thing.
well, I think it comes down to, because I want to hear your answer, because we did talk about genetic entropy a little bit earlier. How are you going to stop this accumulation of these near neutral deleterious mutations over time? Because obviously, if natural selection can't select against them, or because I agree, natural selection is going to amplify, like we're saying with this pre-existing protein, it's going to amplify the most beneficial mutations, but at the end of the day, it's going to get rid of the most
Wait,
detrimental mutations.
hold on. What do you mean by amplify?
So, for example, if we get a truly beneficial mutation, say like this one, natural selection is going to select for that, amplify it, and pass it. Obviously, it's going to pass on through the population, right? Now,
Again, I don't understand what you mean by amplify it.
okay, like for example, in this melanoprotein example, this pre-existing protein, the function of it was amplified because now it has this new function, this new trait based on that pre-existing protein or gene. So that gene, that trait, pre-existing, it's being amplified. I mean, you don't agree that we see amplifications of pre-existing genes and proteins?
What I'm saying is I don't understand what you mean by natural selection will amplify it.
Well, like what happens if we do see, because obviously natural selection acts on the phenotype. It doesn't act on the genotype, right? It doesn't just recognize a single nucleotide. It has to choose the whole organism, every single nucleotide, or nothing at
Okay,
all.
do you have a source for that?
Well, okay, I'm going to ask you a question. Does natural selection act on the phenotype or the genotype? Go ahead.
Natural selection,
Yeah.
it just natural selection is just a process. That's
Yeah,
all
but
it is. It
the
doesn't.
natural selection, it's not some, natural selection is not a god. It's not a deity. Natural selection acts on the phenotype. It doesn't act on, it doesn't recognize those near neutral mutations. I mean, just Google, just write, because you can even see this on Quora, Scientific American, just write, does natural selection act on the phenotype or the genotype? And it will tell you right out that it acts on the phenotype. And that's a huge problem for evolution, because natural selection is now, and if you want to Google it as I'm explaining this, natural selection is just choosing between mutant and more mutant. So if we had 100 people in the room and you killed off 50% of it, you still left with 50% of people who are still more mutant than the last. So at the end of the day, those accumulation of
What are
mutations.
you? What are you talking about when you say mutant and more mutant? There's no. If you have a mutated gene, that mutated gene in the next generation doesn't somehow get more mutated. There's no such thing as more mutated. I mean, this is the thing, is like there's no process. There's no thing that says that something goes from mutation to super mutation.
No,
There's
no,
no.
I'm not saying it goes from super mutation, but if you look, just like how rust slowly builds up on a car over time, it's unnoticeable, it's invisible. You can change the brakes, you can change the tires, you can change the windshield wipers, but you're improving it. But over time, it's overall it's degrading. Eventually that rust is just going to spread and take over. Kind of like these near neutral mutations that go unnoticeable. Because how does natural selection select against something that's unnoticeable? Like, how do you explain and how do you rebut that problem? Go ahead.
How do I rebut what problem?
Okay, so a near neutral mutation is a mutation that is deleterious. Okay, but because we know that our genome is polyfunctional. Okay, so I mean, look at protein moonlighting, for example, that has recently been found out. I mean, a protein that has multiple functions. It's almost like a multifunctional tool. Now, if there's a mutation on a gene that has function, it's going to be deleterious. But if it's neutral, so if it's near neutral, selection can't select for or against it, so it builds up and accumulates in the population. So I'm asking you, how does natural selection stop
Okay,
this?
so in other words, what you're saying is like different eye color is going to cause us to die.
Well, no, no. Obviously, I agree that an example of a neutral mutation can
Look,
be.
the thing is
I'm not talking about fitness, Doc.
neutral mutations occur, and it just means that it's not necessarily a good or bad thing. It's not going to delete anything. It's not going to harm in any way, shape, or form. That's what makes it a neutral. And you are saying that these neutral mutations are going to cause the body to slowly like deteriorate, like all these neutral mutations will cause things to completely just be done away with over time. And that, I need a source for that, because that just sounds like nonsense,
Okay,
to
so
be honest.
so we can agree that neutral mutations happen. We've agreed that they're neither beneficial nor detrimental. Okay, so they build
But
up
you're
and
saying that they're deleterious, which means that they
exactly.
are harmful, but they're not.
Okay, is a single rust molecule on a car, is that harmful to the car?
Enough. The thing is this, your analogy is terrible when it comes to the human body, because because like I said, eye color is a mutation, and it is a neutral mutation, and it's not going to cause over time the population of creatures to die off because of eye color.
Well,
So
we're talking about on a genomic level that if there is any type of change, whether it's a point mutation, whatever it is, on a nucleotide, on a string of nucleotides, it's going to be deleterious to some extent. And I understand you don't like the analogy, but if I look at an encyclopedia, say on a computer that has a virus that say randomly swaps, switches, deletes, inverts letters over time, for a while there would be, just like you're saying, there would be almost no noticeable effect. But over
Okay, and
time, here's the problem: the text would contain more and more errors until it became unusable.
this is another terrible analogy, because I don't see where in anything in the human body is deleting and swapping letters and all this other stuff that you are using. I don't see how anything of the sort is happening.
Well,
So
because what I'm saying, unless, because and we might be able to agree to this, unless mutations do cause a noticeable reduction in reproductive rates, the organisms there, that carry them will be just as successful in leaving offspring as all the others. But in other words, if the mutations aren't bad enough, selection can't see them. Therefore, they cannot eliminate them. The mutations accumulate. That's
that's
what's known as genetic entropy, and that's a prediction of our model. And that's what we see. I mean,
and it's
look at all these.
wrong. It's wrong again. Genetic
You're not
entropy
showing us
is
how it's
wrong.
wrong, though. You're not showing us.
Because you are making up nonsense. Literally, there is nothing that says that neutral mutations, there's no near neutral. There's three types of mutations. You will have a beneficial,
Neutral,
a
positive, and
neutral, or
beneficial.
positive. And there's no near neutral. There's neutral. And neutral mutations are not causing us to spiral downwards.
Okay,
So
so
you are literally spouting off nonsense.
well, so if we look at the ENCODE project, right? They examined 1% of the non-coding DNA, of the human genome for possible function, but they found that at least 80% of the non-coding DNA was transcribed into RNA. That suggests function. Okay, so the trajectory of discovery favors genome-wide functionality. So what I'm saying is, if this trajectory of genome-wide functionality is true, any mutation, whether neutral, positive, beneficial, on a gene that is functional will be deleterious to some extent, because it's going to affect the message overall. How much of our genome do you believe is functional, frustrated atheist?
I don't know, because I'm not a geneticist.
Are you familiar
But
with the ENCODE project?
again, no, because I'm not a geneticist and I don't aspire to be one.
Well, if, like, for example, if we're going to actually test for exact,
And again, I'm going to need sources for this stuff. I mean, this is not something that you can just spout out with and just not provide a source for it.
well, I think if we're looking at models, for example, if we see, this genetic entropy taking place, if we take that
I'm
back
not
to a
asking
point of,
you about your model of how you think this is all happening. I'm asking you for the source of
well, which
your
which
claim.
model makes more sense in light of the evidence? That's what I'm saying. Like, if we see these, tens of millions of nuclear DNA
I
differences
don't
across
I
species.
don't look, I don't care. I'm asking you specifically, what is your source for that claim?
Okay, so you can see from population geneticists themselves that they understand that
Okay,
there
no,
is
no, no,
this.
no. I'm asking you, where are the sources for this? That's
So
I can you give me a source, not
what I
just,
will
oh,
do
look it up. I'm asking you, what is the source?
is I will provide sources and papers in the in the discussion description box. But let me just, maybe this might solve it. Okay,
Well
give
then,
me.
if you're not going to give me something that I can look at, then maybe we should just stay off of that particular topic.
Well, I think it's pretty evident that this genome-wide entropy and degradation is happening. We can agree to disagree. That's fine. But what I'm saying is that is consistent with the biblical model, and that's
But
exactly what we expect.
I'm saying to you that if this is the case, if there is such thing as this genetic entropy, and that you keep saying that there is, and that all these people are saying this stuff, but you're not providing the source or citing your sources for this information, then and to keep going on, whenever I said, hey, I don't know, let me why don't you give me your sources so I can look at it, you are now trying to box me into a position where I can seem like I'm being intellectually dishonest, and I'm not going to do that. So I
Okay,
will
well,
have
I,
to.
I'll give you sources. Okay, the question is man presently degenerating genetically? I'm saying yes. So if you look at papers, and I said I'll post the papers by population geneticists such as Muller, Neal, Kondrashov. I think there's another one, Lynch, Crow. Um, they're suggesting that 1 to 2% of our fitness is declining per generation. But I will warn you, they are
And
evolutionists,
and
and
I
they
will, and I
have.
can tell you, I can give you a lot of a lot of different papers that will cite and say that and claim all these other different things as well. But the thing is I would like the sources, and
Okay, yeah, no, I'm going to give them. And you,
if you're not going to give them to me now and say, oh, I'll just link them in the description later, then we shouldn't talk about it, because
well, can you
if I
find
can't.
well, can you
Go ahead.
find one qualified geneticist that isn't asserting that man is now degenerating genetically? Can you find anybody that wouldn't agree with that?
Again,
I
I
want to.
don't know geneticists. I don't care. I don't know anything about genetics, because I don't aspire to be a geneticist, and I don't look into that.
Well, I'm saying when it
Uh,
comes. Well, I'm just saying when it comes to models, the debate now comes down to a genetics level, because obviously, genes are inherited. Fossils found in the dirt are not. So why would we expect a bone found in the dirt to be able to do something that an animal today can't do, which is add new genetic information to the genome? Can you provide me one example of a beneficial mutation spreading throughout the entire population today? Not in the past, but today.
Again, the thing is populations are, whenever it comes to mutations, populations happen for the population of the area. So you are trying to ask for a worldwide mutation, when we know that these mutations are going to happen in a regional area,
Well, I'm saying, so obviously you use the Milano example, and I'm saying,
which is a
those.
regional thing.
Exactly, but is that type exactly? So is that type of example is that sufficient to provide us the evidence and the empirical data that we need to conclude that fish to fisherman, molecules to man, ponds come to people type evolution has occurred in the past? Is that enough to combat? I know you don't want to talk about this, genome wide degradation, but is that enough to conclude that we have shared a common ancestor with elephants, pine trees, and banana plants? Go ahead.
Yeah, because the thing is when you come to whenever you actually, and everyone will get a can get a DNA test that will show you how, where you come from, like the different areas around the world where you have where your blood shows you where you are from, and you can see that everyone has ancestors that come out of Africa. Um, and your blood will show you that you do indeed come from Africa.
Okay, so what are these
And
genetic
that's
markers? Are we looking at
so
like nuclear DNA differences,
so
PRVs? Like,
I
what are we looking at? Like, what are these genetic markers we're looking at to conclude that? Because if I take a paternity test, I'm going to go back and
that's
realize that humans have produced humans, and humans are still producing humans. And I understand the law of monophyly. I understand we can't outgrow our ancestry. But would you say a population of humans today came from, a population of something that was non-human, say long ago and far away?
do what?
Do you believe? Okay, let's take a population of dogs for. I completely understand the law of monophyly, and I understand what you're saying about these genetic markers and sequencing the genes and concluding that we share these types of relationships, and then build our phylogenetic trees based on chromosome C and all these things, cytochrome C, I should say. But do you believe, say, a population of dogs today came from something that was non-dog long ago and far away?
Sure. Yeah.
Okay, and I understand the law of monophyly, right? But if in all reality, if we do see dogs producing dogs and humans producing humans, why are you going to conclude that humans and dogs are related through common ancestry? Because to me, that doesn't sound like empirical science. Go ahead.
because you have this mindset that you already believe that it's not.
Well, because if I believe, say, genetic entropy to be true, information loss to be true, limits to be true, pre-existing heterozygosity placed into the created kinds to be true, there's no reason to assume that universal common ancestry is true. Therefore, these phylogenetic charts and trees, all they really are lines on paper, because it's based on an assumption that, hey,
No,
molecules from evolution has to be true. Go
no,
ahead.
because the thing is like I've said. So you have in the fossil record we have both
There's no
uh
record. We find bones found in there. We find fossils. Go ahead.
we find fossils. The thing is the fossil record is the record of fossils that we have found. That's
Well,
why
I
it's
mean,
called
obviously,
a fossil
a
record.
fossil doesn't come with a date stamp to it. It doesn't come with an identification of, hey, this evolved into this. We're putting our interpretation on these fossils and bones found there. Because if we
So
look at the
no,
genetic
because
level today,
you can actually figure out when something had died.
um,
This is something that they've always been able to do. I
but
don't
what I'm
understand
saying
how
is,
that's an issue.
how are you going to use these bones? Because, like I said, if we're struggling to provide evidence for massive wide information adding, gene adding, mutations, information to the genome today, why would you expect anything to be different in the past with some bone found in the dirt? Because if you took those bones to a judge in a court and threw them on the ground and said, hey, this is the ancestor to humans, dogs, whatever, I mean, they're going to laugh you out of court. I mean, it's a nice fairy tale and it's a nice story, but I don't
The thing
understand how
is
that's
it's not. The thing is there's not. There, no one's just sitting there grabbing bones and throwing them, saying, "Oh, this is this age." There's actually methods that you can figure out how something died. I mean, in a court of law, you actually do have people who have died years and years and years ago where there's nothing but bone, and they can figure out exactly when that person died, and they can figure out how it was killed, and all sorts of other different things just from the bones alone.
yeah, and you're going to
So
conclude based
how
on
are
those
you
bones.
and all you're saying is that scientists just sit there and grab bones, throw them on a table and say, "Yep, this is this old."
Okay, in my first discussion with Jackson, we both agreed that the big part of the debate comes down to a genetic level, because he even said and agreed that if we were to if every single dog breed today, all 350 dog breeds today, died and went extinct, and we dug them up, say 1,000 years from now, there'd be all sorts of interpretations. There'd be all sorts of stories based on those bones. So how can you conclude that bones in the distant past are accurate based on these interpretations and stories? Go ahead.
So you have dinosaur bones, right? And we find them in different rock layers, and we find them only in sedimentary rock. That's where you find most fossils. You cannot date sedimentary rock at all.
Well, from what? How does a define fossil for the because obviously it's not just a bone. Like, how does something
No,
fossilize, and what happens?
fossilization is
What's the process?
extremely rare.
Yeah, I
Um,
agree.
it doesn't happen very often. As far as when you think of animals that have died in the past, it doesn't happen very often. But yes,
How does it happen?
it happens by rapid burial.
Now, in my model, we predict a global flood, and there is lots of evidence. I know you're going to disagree, but there is lots of evidence that the Earth was once underwater. I mean, there are marine fossils on mountains and in
Yes,
landlocked areas far from the sea.
there is evidence that the entire that if not the
Well, you,
entire, at least a great majority of the world was covered in water.
yeah, and you okay? So and you just also agreed that it's rare, but we also find fossils of animals giving birth, fish being eaten. This suggests sudden and rapid burial.
Yes,
So
I've already said that rapid burial is how you get fossils.
Okay, so what I'm saying is you're looking at these bones and interpreting them based on an evolutionary lens and assumption, but I'm
No.
looking at it and saying, wow, the only way this could have happened is by a global
So,
flood, which we see described and explained in the Bible. Go ahead.
okay, so if you, I've said that that this does happen by rapid burial, and I've said that the only places you find the fossils of skeletal remains is in sedimentary rock.
Yeah.
Do you understand? Do you know what we also find, um, in between these layers of sedimentary and fossils and whatnot?
So are you saying more fossils
Do
found
you
in?
do you know what we find in between? There, yeah, I'm just gonna say it. We find
Well, yeah, yeah,
igneous
okay,
rock,
yeah.
and
Hmm.
that is something we can test. We can figure out in from igneous rock the ages of things.
Are,
Now,
are, are
in
you
between,
dating? Well, are you dating like the bones by the layer and the layer by like how are you
no,
dating this igneous rock?
no. So you date the igneous rock by actually taking the different elements that are within the rock and seeing how old it is by you can do it by potassium argon, you can do it by just about quite a few
Are
different things, and
okay?
potassium argon is the most well refined dating method that we have because
Like
it is the oldest method that we've been using, and it is the most refined that we have been using.
okay, but are there assumptions built into that? Because obviously we understand that there's a radioactive element, right? That's called a parent. That's going to transform over time into a non-radioactive element, which is known as a daughter, right? Say uranium, to lead.
Right,
So obviously
of
over
course.
time, and correct me if I'm wrong, the amount of parent element in the rock is going to decrease, and the amount of, I believe, the daughter rock increases. So we're not really measuring the ages, we're measuring the amount of isotopes present in the rock. So really age is not measured directly. Aren't they based on assumptions like, hey, there's no daughter element present in the rock when it was formed? Um,
No, no, because you can actually know that. For instance, if you can all there are assumptions, yes, when it comes to radiometric dating, um, but most assumptions are usually good assumptions that they do. So whenever, but
okay, well,
you can always figure things out. Um,
I just want to ask you for the audience's clarification, since we're, obviously this is a deep topic that we're going into now. So like, has the rate at which the parent element has it changed into the daughter element? Like, has it been the same? Has it been constant? Because we know some elements vary, in time. So is there was it constant or has it changed? What's the assumption there?
what's the assumption where?
Has the
And
rate at
and
which the
date.
parent element changing into the daughter element, has it been the same? Has it been constant? Has there been any, like, is it based on an assumption that it's been constant?
If I'm not mistaken, and again, I could be very well mistaken, but if I'm not mistaken, I believe that the rate in which the parent isotope uh, um, does
Okay,
with
but
the relationship between the parent and daughter isotopes
okay,
has
but
always been the same.
at the same time, I don't want you to straw man our model, because you do understand that the worldwide oops, sorry. Can you hear me?
Yeah, I can hear
Uh,
you.
okay, the worldwide tectonic activity, obviously during the flood that I was talking about, it can and it is predicted to change radioactive dates, and it accelerates them. So the change has been constant, obviously, since the end of the flood, but it did change during the flood. So these assumptions, if our model is correct and accurate, it's gonna give all sorts of wild, inaccurate dates. Go ahead.
Okay, well, the thing is the problem with your model is the fact that so with these rock layers that we find, we'll find igneous with several different layers of sedimentary, then another layer of igneous, more layers of sedimentary, another layer of igneous, and so on and so forth. And the only way that you can get igneous rock is through volcanic activity. So
Well, I
the
mean, we
thing
would
is
predict that.
you
No, exactly. And we would
how
also, I don't want you to straw
so
man. We predict volcanic activity because in the Bible it says the fountains of the great deep broke open. So this complete catastrophism with
so
volcanic activity, tsunamis, of course, we're going to see evidence of volcanic activity and extreme volcanism. Go ahead.
but the thing is in your rock in your worldview, with the rock layers, they would not end up the same way as what we see in reality. We would not see such layers of igneous sedimentary, because the way that and how long it takes to get sorry, I had something in my throat real quick.
That's okay.
But
Keep going.
so the way that that is you wouldn't get the very second you'll have a layer of igneous rock, then you'll have your sedimentary come down and make its nice little layers of sedimentary rock. You will not get another layer of igneous, and then so on and so forth in that way.
Okay, well, I think you're assuming. I don't think you understand just how catastrophic and detrimental these fountains of the Great Deep breaking open would be. Because when we actually look at the geology of the Earth, present processes really can't explain what we see because it does point to catastrophic processes in the past. Because we see the contorted rocks, that indicates fast folding of soft sediments. We see much geologic evidence that suggests rapid plate tectonics, plus all these fossils found that you admitted are rare. The volcanic activity and the igneous rocks certainly isn't, a problem for us based on what we would expect, retrodict, and predict to happen. Go ahead.
The thing is you your global flood doesn't really match the actual what we actually find. I'm sorry. It just
Okay.
the way things happen, the
Well,
way you can see.
and if you want an observation, look at, for example, I'm sure you've heard this a million times, but let me flesh it out. Look at the eruption at Mount St. Helens, okay? What did that
Okay.
demonstrate? It demonstrated that sedimentary layers, hundreds of feet thick, could be laid down in hours to days. Canyons can be formed rapidly. Multiple fossilized forests could form as the result of a single volcanic eruption. And obviously, we can see how coal seams could be produced quickly. The fact that recent discoveries of dinosaur soft tissue in association with
Yeah, those
really
aren't
intact
soft tissues.
biomolecules suggest that dinosaurs.
Yeah,
Well, I mean,
no.
based on your primary assumption, obviously you have to look at that. And
No, because the one and only source that you have for this, the lady Mary Schweitzer, has already several times come out and said that everything that young Earth creationists have said has been factually incorrect, and they've been saying it for so long now, and
well, she has an
it still
evolutionary
gets
bias
proven.
too.
Well, the thing is okay. Oh, so you're one source who sat there and said that that y'all are using says no, this is not at all what y'all think it is,
Okay, so
even
what does
though
she? Okay, so what does she say that this soft tissue is, and these biomolecules
she's already said
associated
that
with the
that
soft
these
tissue
aren't.
are?
I don't remember her exact words,
and,
but
and which is
she
fine.
has
We
come
obviously.
out several times.
Okay, but the thing is with your, with the because we're going to go back to the igneous rock. Obviously, that's kind of left open ended because the volcanic activity it creates the igneous one layer, like you're saying. But you need to study the catastrophic plate tectonic model because with its tidal waves, it creates another, then igneous again, then another tidal wave from this catastrophic plate tectonics. So the flood, it's not just jumbling things,
So
it really is slow and gradual. So what we see with slow and gradual depositions, like you just said, which is great, that's consistent with the catastrophic plate tectonic model? Go ahead. Because I don't know why you expect there to not be a slow and gradual, because we predict the catastrophic plate tectonic like a sprint. Now we see that it's going slowly. But when we take it back in time, based on the fountains of the great deep breaking open, it's perfectly consistent with the biblical based model. Genetic obviously shows us genetic entropy, information degradation. We
So
see
what is the sources for all of that?
Well, what's interesting is we would there actually is a prediction made, because if we look at seismic data from NASA, it has revealed enormous slabs of, and you can look this up. I'll show you this after. Enormous slabs of cool rock under North America. So down in the core itself, which should be warm, this is confirmation of flood geology, and why is the fact that in the pre-flood ocean, according to the catastrophic plate tectonic model, the ocean crust was dragged down into the mantle. This is called subduction, right? The subduction process. Here's the big thing. The cold ocean crust should still be cold. Since this, let me just finish. Since this occurred only thousands of years ago, even though it has descended into the deep, hot mantle. So there's a prediction based on our model, and that's what science is all about, isn't it? Falsifiable predictions.
Again, where are your sources for that is what I'm saying.
Well, we get this seismic data from NASA. They're the ones that revealed these enormous slabs of. So I'll have to find that for you based on that prediction made. But catastrophic plate tectonics is a very, very strong model. I would suggest looking into Dr. Andrew Snelling's and very many prominent creation. I understand you don't believe creation scientists are actual scientists.
Oh no! Wait, where can you find Dr. Schnelling? Where does he post all of his scientific findings?
Okay, so for example, they made the prediction about these, enormous slabs of cool rock under the ocean bay. But the thing is, you can find his data obviously on AIGcreation.com. But
okay. So
the prediction was made, and it was. Revealed.
Hold on, quick question.
I've got the link for you if you want it. You want the link?
No, what I'm going to ask you real quick is what is do you know what AIG's statement of faith is?
Well, well, I think we're just distracting from all the evidence, because it seems like you are at
no
words overall. I know what
the thing is,
but it's a philosophical. What is it? Okay, so obviously we agree.
What does it state? What does the statement of faith state?
It's the same thing that I state. The Bible is my final authority, and I'm looking at the evidence and the empirical data.
And what their statement of faith says is that that the Bible is 100% true, and anything that contradicts it must be either discarded or thrown away. So regardless, the thing is if you have something that confirms your Bible, you go with it. Anything that does not confirm with your Bible, you automatically throw it away instead of
guess what?
Trying to figure out what is true.
Yeah, but guess what? All the empirical evidence is pointing to everything that I'm telling you in biblical model. But this article that I have is just wait. This article you want about this prediction made about the giant slab Earth crust core, it's a live science and it's secular. So
okay, but the thing is but the problem, live science. If I'm not mistaken, life science has an issue alone with things. But what I'm saying is that I'm perfectly fine with any religious person doing science. I'm fine with that. But I'm not fine with an institution that will.
Too. You're religious as well.
No, I'm not religious.
Well, but see, the thing is, if
what I'm saying,
humans produce humans, you want to say they're related, that's a religion right there.
What I'm saying is that if you have, I'm fine with any religious person who does science. As a matter of fact, Dr. Cy Garter, who is a Christian, is also a firm believer. In Christ and all that good stuff. But he also accepts evolution. And he does that
He believe,
because he
well, he
knows the
believes in
science is
evolution. I would
correct.
say believe with capital B.
It doesn't matter. It doesn't matter what you say
Well, you
because
don't
it's already
accept.
settled.
You don't
Yes, you
accept that
do.
you don't accept the
But
idea that humans
anyways,
and banana plants are related through common ancestry. Well, I just want to read you a quote,
yes, you
okay?
can.
So I just want to read.
Let me guess. You're going to read me something that has to do that somebody said back in the early 1900s or something like that.
No.
Correct?
Actually, this was in 2003. This is a statement.
Okay.
So this is a statement from an evolutionary scientist. His name is Professor Paul Davies. This is what he said. Science takes as its starting point that life wasn't made by a god or supernatural being. It happened unaided and spontaneously as a natural process. Oh, well, look at that. Evolutionary bias. Looks like you guys have to discard any evidence that points to a biblical model and to creation and a creator. But now you're looking. So that seems like a very fallacious argument that you use.
Oh, hold on, because I'm getting on Google real quick.
I've got another
You
one.
said
Look at
Paul
this.
Davies. Hold on, you said Paul Davies.
Professor Paul Davies. Quote, it's from The Origin of Life, Penguin, London, page 4. I've got another one too. Francis Crick. Biologists must constantly keep in mind that what they see was not designed, but rather evolved. That one was in 1988. Sounds like there's a whole lot of
Say that
bias
again.
going on.
Say that again.
Okay, so this one was by Francis Crick, Nobel laureate. Biologists must constantly keep in mind that what they see, Francis Crick, C-R-I-C-K. Biologists must constantly keep in mind that what they see was not designed, but rather evolved. Quote unquote. In other words, pine trees and elephants are related through common ancestry. Listen, there's a huge bias. At the end of the day, these
The
phylogenetic
thing
trees, these
is
phylogenetic charts, they're lines on paper because the
what
empirical
is
data.
science?
Science means to know. How do we know? Testing, demonstration, investigations, retesting. That's what we know. We know there's change, but are there limits to change? Let me ask you a question. Can we get it? Because a dog and a mouse, they're both mammals. Can we get a dog as small as a mouse? Because we do know there's animals as small as a mouse, like a mouse. Or are there limits, whether it's physical, genomic? Go ahead.
What did you say again?
Okay, we know dogs and mice are both mammals. Do you believe we can get a dog as small as a mouse? Because we do know there's mammals / animals as small as a mouse, like a mouse. Do you believe there's physical limits, genomic limits? Do you believe there's any limits at all?
Of course there are limits. I've already said that from the very beginning.
Now, do you believe that dogs and mice are related through common ancestry?
Yes.
Okay, so I don't understand how there can be limits. By you admitting limits seems more consistent with what I believe.
let me ask you a question.
Yeah, go ahead.
Are you and your cousins related?
Me and my cousins are related, and we're all human. Yes.
I don't. The human part is irrelevant. I'm just asking you if you and your cousins are related.
Yes, we're related.
Okay, and are you and your grandparents related?
Yes, we are.
And are you and your great grandparents related?
Yes.
Okay, so you have a relation with all these people, correct?
I do have a relation with all these people. Yes.
All right, so whenever you're looking at creatures of the mammal aspect, they are all related. They are cousins to each other.
Well, I
Just
mean,
like
you could.
we are cousins
You could
to
say
the
that like a
bonobo.
mantra, but obviously, if we don't see any
No, it's not a mantra. It is.
If we don't see any
there is-
information adding mutations, if we see genetic entropy as a fact, obviously mice and dogs.
Which we don't see genetic entropy as a fact, but okay.
Okay, demonstrate to me.
Boldly assert it.
Okay, so what's the best evidence to demonstrate the fact that mice, dogs, humans, and elephants are all related through common ancestry? Where's your empirical evidence to prove such a thing? Go ahead.
Well, you can look at genetics and find that we are all related in some way.
But I thought you didn't want to talk about
genetics. Well, I don't talk about it, but the thing is you asked me where can we find the evidence? It would be in genetics. But I'm not going to speak on specifics of genetics
Okay, which part
because
of
I
like
can't.
are you looking at like mitochondrial DNA differences, nuclear DNA differences, cytochrome C? Are you looking at ERVs? You know,
What part of I'm not going to specifics on something I don't know about
okay, so it
or
sounds
to
like you're
understand.
choosing to believe in some because if we
No,
know,
I trust in the people who have used this, who go into this scientific field
okay, so you trust in
with
your
this.
science fiction apologists and
No,
apostles of your science
no.
fiction based religion. Because if we know that these
Where
nuclear
where do
DNA
you where
differences,
hold on, do you get that scientists are in a some kind of cult religious belief thing?
I just read to you a bunch of quotes showing their bias. I've showed you that the
You've
empirical
quote
data
mined
does
it.
not point
You
to.
have quote mined is what you've done.
It's
Because
not
the
quoting
thing
because you
is
can go look
you
at it
it's
and you can
quote
see for
mined.
yourself.
Okay,
Even
and I
Richard,
guarantee you I will find 9 times out of 10 everything that you've said about when it comes to quoting other individuals that they are taken so wildly out of context.
okay, let's go
Because
back
this
to
is
your.
exactly what young earth creationists do. You can sit there and find a quote um from Darwin himself where he's will sit there and admit that he has not found that they have not found transitional fossils and be like, ha ha, but that doesn't mean that. And as a matter of fact, in his lifetime, about a year or two after he said that, they found transitional fossils. And then they kept finding them. And so you can find all these different quotes from
You
all
don't
these
find
different
transitional
individuals.
fossils, you
And
find
then you
fossils
will find,
found in
and
the
then
dirt.
you
Why would you
will,
expect a fossil to do something that an animal today
oh
can't do?
my
Add
God,
new information to
I
the
was
genome.
talking. I was
Well,
talking.
yeah, but you're going on
You
a
can,
loud rant. You need to calm down,
and I
relax,
was about
breathe.
to be finished. I was about to be finished. What I was saying was
Okay,
that
finish what
you
you're
can
saying.
find, you can find all these different quotes from all these different people. I guarantee you can go into my past and sit there and show if I had it written down or said it on anything where you'd find that I said that I believed in God because you will because I was a Christian. But that doesn't mean now it's the same. It's true. So you can, the more you quote mine, the less likely I'm willing to accept that because you're sitting there saying, well, listen to what this guy here said. Oh, listen to what this guy here said. It doesn't matter because I don't have the context in which they're saying it.
Okay, so back to the file because obviously we were talking about the idea that mice, dogs, humans, elephants are all related through common ancestry based on these nuclear DNA differences, based on these genetic markers. But like I said before, the ENCODE project is revealing to us that 80% of the non-coding DNA is actually transcribed in RNA. That suggests function. Look at protein moonlighting, like I said earlier. That's a protein that has multiple functions, much like a tool with multiple abilities and functions. Now, what's important about that is the trajectory is pointing towards regulatory functions, which would indicate when and how fast to make specific proteins, embryonic development, the timings of protein manufacturer.
Hey, keep going. I've got to mute myself for a minute.
No problem. Stagings of proteins for construction of molecular machines, switches. I mean, there's just so much, especially when it comes to placental and embryonic development. We know so little about that. When that egg meets the cell and that process begins, there's so much genes and there's so much information involved in that a lot of these apparent and suggested junk DNA or AREs or endogenous retroviruses, they actually have very important functions. So the fact that we're just beginning to understand the developmental process, how coding and non-coding DNA coordinate, when, where, and how structures are sequentially put in place to produce a fully functional genome. Now, these differences in these genetic markers across families they're going to have different functions based on the family that they originate in. Now they can't be used to build that phylogenetic chart. So if you understand what I'm saying, now they really are evidence for
you need
design.
a source for that.
Okay, go read ENCODE. Go read the fact that 80% of our non-coding DNA is transcribed into RNA. Let me ask you,
the source
how much
for it
do we
is what
know
I'm
about
asking for.
embryonic development, though?
Am I an embryologist? I'm pretty sure that there are embryologists who will disagree with whatever it is that you're about to say, but I'm not an embryologist. So why are you going to ask me about embryology?
So, okay, if we look at similarities then as well. Okay, so I'm saying that these non-protein coding regions are functional. We don't have to talk about that. That would be a prediction that we're making. That would suggest design. Now, if we actually look at, say, Microsoft PowerPoint, Word, and Excel, and we sequence the lines of code in those programs, we're going to conclude that there's many, maybe even 90% similarity within those programs. But at the end of the day, that doesn't prove either universal common ancestry or design, because there's that competing explanation. That's why the battle.
And that is a terrible analogy, because the simple fact is if you were to actually use this analogy, the thing is you can figure out that Microsoft Office or Word, Excel, PowerPoint are all the same, have the same common ancestor due to the fact that they're all from Microsoft, and that you can trace it back to the fact that it is from Microsoft. And so you can find the coding for that.
From the designer of Microsoft. That's exactly what I'm saying.
But the thing
God would be the designer of life.
But the thing is you are saying that you are acting as if that is a great analogy. It is a terrible one.
I think it's perfectly analogous. It shows that there's a competing. Are you familiar with Dr. Francis Collins? Because I know you want sources, because Francis Collins, right? He was
saying names. It's not sourcing. Saying a name is not sourcing.
He's a very famous evolutionist.
Okay, but the thing is whenever you are sourcing materials, you don't just throw out random names. What you do is you actually give the person, like, for instance, in an email or anything, where you give the person the name of the person who said it and where he said it from, so that way they can look into it and figure it out within context.
And so what I will do is post you. I've given you quotes. I've given you sources, papers by population geneticists, evolutionary biologists.
You are not giving them in context.
So what are you using to build these phylogenetic charts? Because I hear you talk a lot about this fancy story of universal common ancestry, and I understand the law of monophyly. We don't outgrow our ancestry. But if I'm showing you these nuclear DNA differences, these genetic markers are showing function and design, you can't use those to build your phylogenetic tree. Like, I don't understand why you can't seem to see and understand that, because function proves design. It's not evolutionary leftovers.
How does function prove design?
Okay, if we're looking at these evolutionary leftovers, there's not going to be substantial function.
What are our evolutionary leftovers?
Okay, so your ancient repetitive elements, obviously your selfish genes, your ERVs, those sections in your non-protein coding regions that serve no apparent function, like the gulo pseudogene, right, with the vitamin C. I mean, evolutionists constantly parade about how these regions don't have function. Why? Because they're evolutionary leftovers from past ancestry. I mean, don't you understand the theory and idea behind pseudogenes?
I have no idea what any of that is, because I'm not a geneticist. However, how is function proof of design was the question.
Because function and design go hand in hand. When we look at modes of transportation, okay, we're looking at an evolutionary model versus a biblical model. If God created us with pre-existing heterozygosity, we're going to expect, predict, and retrodict that these DNA differences are not based solely on mutations, but based on intentional design. Evolution would predict, and they have, that they're Pseudogenes.
how
I've already given you the answer. I
no,
understand you
you
don't
haven't
like
given
the
me
answer.
any. You haven't given me a single answer on how function is proof of design.
Because if you're using these genetic markers, okay, these evolutionary leftovers to determine and build your phylogenetic trees, if
This
they
is
have function
still,
which isn't
you're not
predicted,
answering.
no,
I'm
you just don't
asking
like
you
the.
one specific question. How does function, how does function in anything prove design?
Here's the answer. If you don't like it, then like it or lump it. Because creationists predict function, evolutionists predict junk. That's the answer to
I
your function
don't,
question.
that, and it is a terrible, it's a non-answer is what it is. That's exactly what it is. It is a non-answer. It's like if I sit there, if you ask me, oh, well, how does this prove that? And I give you some irrelevant nonsense like, oh, well, how do you know that the ocean is blue? Oh, well, look at the trees.
Okay, an
That
engineer,
it doesn't, it's nonsense. So
an
an
engineer,
engineer would
it's not a
go
non
ahead.
sequitur because an engineer, he's going to create functional things. He's not going to create
Okay,
junk. God,
but
it's not in God's character to create junk,
also,
as evolutionary
also,
would predict.
also, an engineer will also make the shortest route of things possible because that would mean that it would be the best. Like for instance, the nerve in
So are you
the
going to use
biggest
bad
the
design
nerve
as
in
an
the
argument against God?
what I'm saying is that if everything is designed and
Remember,
has
we're degenerating though from the fall. So you don't want to straw
so
man us
so
because we'd
you have
expect
okay
degeneration.
so you have giraffes that had
I
shorter
understand what you're
nerves.
saying. Yeah. Are you talking about
Where
is
do you
that
have
within their brain
goes
down
down
into
from the
their
brain to their heart
yeah?
up to their throat? Yeah, so
See,
we have
yeah, but
giraffes
shortest
that
route is still designed. If I were to construct a house and
their
afterwards I'm
shortest
standing
route
and
is
looking at
the
that bricklayer and think, oh man, I missed this piece or that piece, but it doesn't. It's not evidence against design, and we don't understand how that original creation was compared to now, which has
oh, but
you
the
know,
thing is
been
that they can't
subject to decay.
they haven't changed in quite a long time. Giraffes, the evolution of the giraffe hasn't changed in quite a long time when it comes to the change that your model predicts. So how do we know that these giraffes were different 2 or 4,000 years ago or whenever?
Well, based on
How do we know that they
pre-existing
were different?
Okay, based on pre-existing heterozygosity, okay, these millions of DNA differences and a least point of entropy, going from a shift from heterozygotic, say, DNA sites to homozygotic DNA sites, it's gonna and migration and radiation from the flood and things like this, it will isolate certain populations and it will sort out and thin out the genetic information system. So this population of giraffes
So
we're looking at today is far
mhm.
inferior to the original
So then
kind of giraffe.
the original one, how do we have evidence that shows that this original giraffe had a shorter nerve?
I wouldn't. I would say it's a good inference to say that, or it's a good indication that. No, I wouldn't
Well,
say we have
you
evidence that there was a shorter nerve. Like I don't know
so
how the original kind
so
was built.
for right now, since we don't have any evidence that shows this, so for right now, we can pretty much go ahead and say that 4,000 years ago, when this great flood happened, the giraffe has been the same since then, or
Well, I would.
even before then.
Well, like I said, based on that heterozygotic pre-existing information, the shift towards homozygotic DNA sites and that loss of information and that isolation based on migration and radiation from the flood, of course, they're going to look totally different. They're still going to be a giraffe. They're still going to be part of the giraffe kind.
I
They're
don't
going to be
I wasn't saying that they weren't. I'm asking you that since we have no evidence to prove otherwise, for now we can say that giraffes have been the same since before the fall or before whatever, before the flood or whatever.
well, do you know what I mean by like because I don't want to just say
Oh,
words you don't understand.
speaking of
Yep.
which, when it comes to the flood, I have a question.
Yep.
How did kangaroos get to Australia?
Very good question. So, after the flood, okay, so there
Mm-hmm.
would have been, based on the extreme climate change, temperature changes, especially the volcanic ash, you know, going into our atmosphere, it would have created an ice age. Okay, so there would have been land bridges that these animals would have
Okay.
migrated from, but after the
Right.
ice age and the climate changes decreased and went back to
Mm-hmm.
equilibrium type, temperatures, those land
Mm-hmm.
bridges, obviously there would have been massive still flooding. That's how we would explain the Grand Canyon. Probably happened 100 years after the flood, but after this ice age, after these migrations took place, you'd have these various populations, say kangaroos. Now they're isolated in these
Right. They're isolated
areas,
on
right?
the island. Yeah.
Yeah,
Okay.
correct.
So do you know the distance between the Middle East, where the Noatic flood took place, to Australia is?
I would imagine it's quite far, but I wouldn't say that a land bridge is necessarily the
Quite far.
entire. Well,
Right.
but
But the thing is so to get from there to Australia, they did they walk like all day and all night to
okay,
get
so
there, or
let's
would they
say
have
it's
stopped in places to rest or
well, let's
whatever?
say it's 6,000 miles, and obviously
Right.
the
Yeah,
immediate
we're
post.
neither one of
Yeah,
us know the exact distance, so we'll just do not even an educated guess, just a guess and say 6,000.
so let's say 6,000 miles based on these raised or decreased water levels, whether it's before or after the ice age and the isolation period. Yeah, obviously during the migration period, there would have been moments and periods of rest for sure. But the thing is,
Hmm.
based on the fact that they can carry their young in their pouches, they'd
Right.
be able to migrate further quicker and more sufficient than say a lot of the other animals, placentals that came off the ark, right? So we'd expect the kangaroos to be the furthest that they are based on those types of factors.
Okay. So I have a question with this. So we have two kangaroos, which do you know the how long a kangaroo uh how the reproductive cycle of a kangaroo is?
Well, I don't think we can look at a kangaroo today and say that that was the exact
Well, we can we
species of
can we can
kangaroo.
see, but we can see. So even if I'm sitting aside, regardless of whichever model you want to go with, and it's just saying that we can say that that with the with the cycle changes of kangaroos today, we can say that we can almost guarantee that the the life cycle changing may not have been different from today than it was at max 4,000 years ago. We
Well, we
can
would say
almost guarantee
4,000.
that.
Well, I mean, we would say 4,000 years ago, there still would have been many more heterozygotic DNA sites, right? So we're still going to see that, amazing potential for the variation and obviously for the speciation based on migration and post flood radiation. But I understand what you're saying. But my answer is yes, there would have been periods of rest. There would have been
Hmm.
land bridges. There would have been higher water levels versus lower water levels, whether it was pre or post ice age. And at the same time, humans, because we know that they do this today, they would have possibly taken various animals to certain parts of the world after post flood, and
Okay.
it's not a big deal for them to be isolated there based on environmental conditions. Go ahead.
Okay, but the issue with that, but you can't even really use that when it comes to the kangaroos, because of the fact that you have Noah and his four sons and their wives, and
Well, I mean,
there won't be very many people to take anything anywhere.
Well, it depends what the reproductive rate and how quickly the population grew, right? Because we would expect certain, I guess, varieties of human, right? Neanderthals, Homo erectus. I mean, these features we would say are based on post-flood environmental conditions, whether it's ice age, whether these humans that had the Neanderthal type characteristics, whether they were isolated in an area that was more in effect and affected by the ice age itself. So that population growth would have definitely been exponential following the flood. Go ahead.
So you're saying that post flood, are you under the belief that after the flood we stopped living 900 years old and whatnot, that we
Yeah.
went back to a more century long lifestyle, right?
Well, what's funny is, based on, genetic entropy, which I was talking about, the actual decay curve
I
that we look at based on these accumulation and near neutral mutations, it's the exact same decay curve that we see in the book of Genesis, starting with Adam at 900 years old, going down to, I think, Abraham post flood died at 120. And now our current life expectancy is 75. So
right.
even for these kangaroos, they would have had a better chance of survival um, based on that least amount of degeneration, right? So yeah, I think the age decline is completely consistent with what we would say is the mutational decline. Go ahead.
But uh, that's a long roundabout way of saying yes, that we went from
Well,
900
because
to
I don't want to just say
100.
yes and give no reasons to back it up. I'm just saying that the
Well,
curve is consistent with the age decrease from creation to post flood to now. Go ahead.
so so with the lifestyle, with the way that the reproductive system works, is that usually by the age of 40, um, or at least in the 40s, women tend to not be able to reproduce as best as when they were younger. And almost by the age of about 45 to 48, I don't know the exact date or the exact age, but they tend to not be able to reproduce. Period. That's when they start going uh, through the lifestyle change of being, starting to become a more towards menopausal age, and their reproductive system tends to really decline. Um, which is why it's very hard for women over the age of 40 to become pregnant. So let's just go off with the age of 40. So with the flood killing off a great majority of the population, you believe that within 40-year lifespan, or 40-year reproductive span of each generation, and not even 40 years, because you have to wait for women to become to be able to reproduce, and that has been shown to be roughly around what now it's different, but it's like
Are you
now a
saying
lot
that the
younger than what it used to
population?
be.
Are you saying that the
I'm saying
population growth curve isn't consistent with Noah, his sons and
I'm
wives,
wanting
and
to
their wives
know
coming off the ark?
how can we go from, like, what is it, a family of four different families
To all
having
the okay, to all the
children, to
life we see
having the,
today.
yes, to having all the human life we see today?
Well,
How is that
I've
at
already
all possible?
I've already explained that. Okay, well, for one, there's going to be low genetic diversity among humans versus high genetic diversity among animals, right? The created kinds. But what I'm saying is there's a strong linkage between nuclear DNA heterozygosity and mitochondrial DNA mutation rate. So just like I said at the beginning and referred to Mendel and his work with pea plants, we can see these recessive and dominant traits, and we can see based on this heterozygotic DNA sites and these tens of millions of DNA differences, that variety of human would not have been a problem at all, especially with a point of least genetic entropy at that point. So I don't see, based on a low genetic diversity, based on heterozygotic DNA sites, I mean, I don't see that as an issue at all.
That was a great non-answer, but
okay, so what?
so
Actually, just a second. I would just say the short answer is pre-existing variety. But we've gone 2 hours. We agreed hour and a half. I'm going to give you a few minutes or however much time you need just to conclude it. We can do this again. I think it's been fun. I think everyone's going to enjoy re-listening to it. It's been 2 hours. And give yourself a little wind down. Say a few things. And then I'll do the same, and we'll depart. And I hope you had fun, and we'll have a good night. Go ahead.
Okay. Well, I would just like to say that there's a lot of different areas that this was too much of a broad topic, or too much of a broad conversation to have, that I think that the next time that we speak, it should be a more narrowed topic, because there's so much to go into that if we narrow it down, it'd be a lot better. Like if you want to go off of I don't know, just anything that narrows the topic down, that'd be great. But I would like to I don't know, I just would like I said, it just, we need to be able to talk about something that's more narrowed down, so that way we don't get so off track on different things, on different tangents, because that's what happens with broad questions. So
and I appreciate you you coming on. I think based on say the biblical model, based on the evolutionary model, I think a wide range of topics are expected. But I think a lot of this does come down to testable, falsifiable predictions, and a lot of what I said in regards to pre-existing heterozygosity, pre-existing variety, to explain all the life we see, genetic entropy, the accumulation of near neutral mutations. Like I said before, I don't believe natural selection can stop the accumulating damage, much like a rust on a car. And I think we're going to see in the future that a lot of these predictions being made by creationists, and time will tell. But what we're predicting briefly is that the linear relationship, say, between the number of species and the time that we've discussed, it's going to be observed in more families, and that these plots, coupled, say, with measured mutation rates, they're going to reveal correct rates of speciation. Okay. And also expected is a huge thing, which I touched on earlier, and we chit-chatted about a little bit, is that most non-coding DNA will be functional, and that's key. Okay. Differences in mitochondrial DNA sequences, say, between families, they're expected to reflect functional differences. But here's the answer to Dr. Herman Mays, and he asked this question. He asked Ken Hovind, but they're not just to be due to neutral mutations. Okay, so they're functional differences. That's how we would explain the neutral variation that Mays constantly presses us with. And measured mitochondrial DNA mutation rates and known mitochondrial DNA differences, say, within families, they're expected to fit the creation timescale. And what we're doing is we're assuming a constant mutation rate, and that created kinds, they started with no mitochondrial DNA mutations, but of course they did start with pre-existing heterozygosity. So thanks for coming on. I'm glad Non Sequitur Show was in the live chat here, and maybe we'll have a round two. I'd love that one day. Go ahead.
Also, Non Sec even said that maybe you should get you and Warning Good People, who's also in the chat, on for a rum and coke night.
I think that would. I'd like to go on the Non Sequitur Show. I've had 2 discussions with what's his name, Skylar Fiction. I've had 2 discussions with Jackson Wheat. Sokka account, maybe the next, obviously you know, your channel, you're pretty popular on YouTube, and maybe the next step is to hit up some non sequitur show for some Coke, rum, wine, and chips. Sounds good to me. Okay, brother, you have a good night, and don't work too hard. I know you're at work right now, so have fun.
I try to. My life motto is to make sure that I never work too hard.
Very, very good motto to live by, my friend. Okay, man, take it easy, and thanks for the conversation, guys. And until we see again, standing for truth is going to bed.